Hi, students, and welcome to today's lesson. I'm Mr. Simpson. Today, we will explore the question, what objects can cause a solar eclipse? Are you ready? Grab your pencil and your science journal, and let's get started. Let's look at our sun, earth, and moon cards. Remember, the information on these cards shows us that these three objects are very different sizes. The moon is about 1/4 as wide as Earth, and the sun is about 109 times as wide as Earth. In our last lesson, we made a physical model of the sun, earth, and the moon. How did we represent the different size of these three objects in our model? That's right, we used a different size ball to represent each object. What are some other ways we could represent the sun, earth, and the moon? I have an idea. Let's use different size paper cutouts to learn more about the relationship between the sun, earth, and the moon. One of these cutouts represents the sun. The other cutout represents the moon. Which cutout do you think represents the sun? Did you say this larger cutout represents the sun? That's right. So this smaller cutout represents the moon. What do you notice about these cutouts? Do you notice that the moon cutout is much smaller than the sun cutout? I noticed the same thing. I will hold the moon cutout about an inch in front of the sun cutout. Does the moon block the whole sun? Thumbs up for yes or thumbs down for no. Thumbs down. When the moon and the sun are arranged this way, the moon does not block the whole sun. If the moon is so much smaller than the sun, do you think the moon can cause a solar eclipse? Maybe you are not sure. When we look in the sky, the moon looks like it is big enough to cover the sun. But in this model, the moon cutout looks too small to block the whole sun. Let's investigate to find out whether the moon can block the whole sun and cause a solar eclipse. I will place the camera here. The location of the camera represents the location of Earth. The sun cutout on the wall represents the location of the sun. Now, let's hold the moon cutout an arm's length away from the camera. What do you notice? When we hold the moon cutout closer to the camera, the moon cutout looks larger than it looked before. But I can still see part of the sun. So the moon does not completely block the sun at this distance from the camera. Now let's hold the moon cutout even closer to the camera. What do you notice? The moon looks even bigger now. The moon looks so big, it covers up the entire sun. So the closer the moon is to the observer, the larger the moon appears. And the larger the moon appears, the more of the sun it covers. Look at this photograph of a solar eclipse. Remember, the sun is 400 times farther from Earth than the moon is. Think about what we observed in our investigation. Do you think the moon can block the whole sun as it passes between the sun and Earth? When the moon cutout was closer to the camera, we could not see the sun cutout. And we know the moon is much closer to Earth than the sun is. Do you think the moon can block the whole sun because the moon is closer to Earth than the sun is? Yes, I agree. The moon can block the whole sun as it passes between the sun and Earth because the distance between the moon and Earth is less than the distance between the sun and the moon. Let's look at our class model of a solar eclipse. Right now, our model shows what people see from Earth during a solar eclipse. How can we use our new knowledge about the sun, Earth, and the moon to show what a solar eclipse might look like from space? Let's start by making a new role called View from Space. What should we draw in the before, during, and after sections? Well, we can draw the sun in the same place in each section. And even though Earth orbits the sun, Earth does not move far during a solar eclipse. So we can draw Earth in the same place in each section too. We also know that the moon orbits Earth. So let's draw a line around Earth to show the moon's path. Now, where should we draw the moon before an eclipse? We know that before an eclipse, The moon is not yet between Earth and the sun in its orbit. So let's draw and label the moon here. Where should we draw the moon during an eclipse? During an eclipse, the moon blocks the sun. Do you think we should put the moon directly between Earth and the sun? Yes, let's draw the moon here. Finally, let's draw the moon after an eclipse. After a solar eclipse, the moon has moved along its orbit and is no longer directly between Earth and the sun. So let's draw the moon here. Let's also update our explanation. We can say a solar eclipse happens when the moon passes directly between the sun and Earth as the moon orbits Earth. Great. Your task after this lesson will be to complete the class model. Let's look at our question chart. Do you think we can answer any of our questions? I think we can. This question says, what causes a solar eclipse? And this question asks, what blocks sunlight during a solar eclipse? Can we answer these questions? Show me a thumbs up if you think we can answer these questions. Show me a thumbs down if you do not think we can answer these questions. Thumbs up. We can answer both of these questions. We learned that the moon causes a solar eclipse. When the moon is directly between Earth and the sun, the moon blocks light and thermal energy from the sun, which causes a solar eclipse. Let's move these questions to a new section of our question chart. We can call this section Answered Questions. What other questions can we answer? This question asks, are there other kinds of eclipses? Can we answer this question? Thumbs up for yes, or thumbs down for no? Thumbs down. We do not have enough information to answer this question. Let's leave this question in our unanswered questions section. Can we answer the question, where can you see a solar eclipse? Thumbs up or thumbs down? Thumbs down. We do not have enough information to answer this question. Let's leave this question in the unanswered questions section. What about this question? This question asks, when does a solar eclipse happen? Can we answer this question? Thumbs up or thumbs down? Thumbs up. We know the answer to this question. We know that a solar eclipse happens when the moon moves between Earth and the sun. Let's put this question in our answered questions section. We have two questions left. How often do solar eclipses happen? And how do we know when a solar eclipse will happen? Can we answer these questions? Thumbs up or thumbs down? Thumbs down. We cannot answer these questions yet. We will leave them in the unanswered questions section. Let's look at the questions in our unanswered questions section. What do we need to know to answer some of these questions? Do you think we need to learn more about eclipses and whether there are different kinds of eclipses? I agree. And I think we need to learn more about the moon's orbit around Earth and Earth's orbit around the sun. Scientists cannot always answer all of their questions. And sometimes when scientists do answer questions, they think of new questions. But that is okay. When we have unanswered questions, it just means we have more to learn and explore. Let's review your task for today. Complete the class model.